A confirmation about the audio, please, guys. If the audio is clear, kindly confirm. Thank you. Sashi, while in collision phase, why the moon doesn't cool by rain either? Why does rainfall happen? Rainfall happens because of the presence of water vapor. So if you don't have water vapor, then you won't have rainfall. Moon has got ice. The region where I hope you have followed current affairs significantly, the region where Chandrayaan basically where it landed, Chandrayaan 3 where it landed, that is the region of the south pole of the moon that has got a significant portion of ice. But if it is not heated enough, and if it doesn't have enough atmosphere, it won't have the cloud and the occurrence of rainfall. Okay, right? Abhay, what is the confusion that you have with ideal? See, in case you still find the portion of ideal, etc., a bit difficult to imagine, I would suggest to you that go for the on our YouTube page. We have put animated videos. I have put a certain number of animated videos there, or even in the pre-recorded lecture, I have put an animated video about ideal. So, in the our YouTube channel, that is Byju's IAS YouTube channel, Byju's Exam Prep YouTube channel, search for ideal. You will find the animated videos that can also help you. Okay. Today webinar, what's time started? Today webinar 8:30 started. It will start at 8:30. Okay, and we stand in circle surface, but we see a flat surface. Yes, because you are very insignificant compared to that circle or that sphere. That is why you see the flat surface. If let's suppose you would have been so tall, if your height would have been 2 kilometers, you would have seen the curvature. But if you take a look at the sea, if you have ever been to a region where you have a lighthouse, go stand on the top of the lighthouse. You will be able to observe a slight curvature, ever so apparent. And also think about it. When you take a look at the sea, and if a ship is coming towards you, it is not the bottom of the ship that you are able to see. Initially, you are able to see the top, and then slowly and steadily the lower portions they start appearing. So that tells you that it is curvature. Okay. Why doesn't moon have core? Moon will also have core. It will not be the same as the Earth's core, but moon will also have core. Means, is there possibility that in future there is life in moon? That is what every country is trying to explore. All the countries, if you take a look at their future space missions, China, for example, wants to establish a permanent base on the moon. So moon is considered to be that area where all the countries are trying to establish a base. That is why Chandrayaan 3 was so unique, so special, because it explored the region of that icy area, and it is basically seeking a kind of a future habitation there, so that by that ice, if you have the presence of sun, we have enough technology to convert that ice into maybe water, and then by that water we can produce hydrogen and oxygen that can be used as a fuel to fill up the rockets, which can then propel us to Mars. And then that is the future planning, that in Mars also you will have certain areas. Mars also has some of the frozen ice which is present underneath the surface. So from that, again, you will do the same thing. You will have some habitations, some centers there also, or some base there also, and that can be used for intergalactic travel. That is what the future lies in terms of space exploration. Okay, please clear my doubt. Okay, what is your doubt? If the moon has come out of Earth with the same material, see, this is what I will not always appreciate, because it is the initial sessions of the module. So on 709 you have sent a question, and on 710 please clear my doubt. All the doubts will be taken care of. But if you start putting up that kind of a repetitive thing, I will ensure that only the SMEs will take your doubt. I won't take your doubt. So be patient and ask that question. Okay. So if moon has come out of Earth with the same material, then why does it also become the same planet as Earth? Okay. Now listen to this carefully. It is a kind of a basic science. So when we talk about Earth, if the atmosphere would not have been present, then would planet Earth have the green conditions, the ice, etc., that you see? No, it would not have the water, etc. It would not have been present. Plants, I hope you are aware, it is not as if the planet got into existence and plants were first things that a mango tree came up, and then there was mango tree, apple tree, and then people came and lived there. No, basically, if you think about it, our atmosphere has got a substantial role to play in terms of shaping the life on the planet. Why is it that atmosphere came into is there? Why isn't it that the gases escape into the outer space? It is bound by the gravitational pull of the earth. It is the gravitational pull of the earth which holds the gases. Moon has got a mass which is 1/6 of planet earth. So the gravitational force of attraction by moon will also be very less. That is why in the case of moon, you don't have that persistent atmosphere. Everything has escaped into the outer space. If you don't have that atmosphere, what is going to trap heat? And in the portion of climatology, we'll study about this also, that the only reason that planet Earth is able to maintain that heat, that temperature, is because of the presence of atmosphere, the gases, the greenhouse effect. Now, every few million years, the planet goes through a phase where carbon dioxide moves in abundance in the atmosphere. And whenever that happens, there is heating. Otherwise, in moon also, the daytime temperature is high, but the nighttime temperature goes to around minus 200 degrees Celsius because there is no gas there to trap that heat. Why is there no gas there? Because the gravitational pull is so very low that everything has escaped into the outer space. Okay, right? Why doesn't moon? Because why doesn't moon have heated molten? So if I take a look at all the questions and the aspect of it, most of you are worried about the same thing, that you are saying that moon has separated from planet Earth, but moon is different, Earth is different. How can you say that from the same thing? Basically, when you have a child which is born out of your human, so that also looks like human. Why isn't it the case that moon also looks like the Earth? Right? Many of you have that same kind of a doubt, that heat retained in the interior. Why doesn't moon have heated molten core? All of that, that is the same kind of a doubt. Because, first of all, moon is very small. It consists of only some materials from the exterior. Life that you see, when you liken it to the portion of Earth, I am sure you are not thinking about the mineral composition of the moon here. I am sure that is not your kind of doubt there. Your doubt basically is that why doesn't moon have life? If I'm not wrong, that is basically the doubt that you have. That is basically because the moon doesn't have the gases, atmospheric gases. Why it doesn't have the atmospheric gases? Because it has escaped. And that is why when the moon cooled down, the small portion, the small size of the moon cooled down, it could cool down much more quicker. In the portion of planet Earth, it was so very large that the interior maintained its heat, retained its heat. Okay. Seema, if the moon is not a star, why it shines? So does the moon shine equally every day, Seema? Please don't say yes there. I will be heavily disappointed. Moon basically shines because of the light that it reflects from the sun. The solar rays fall on the moon and that basically is reflected. I hope we are aware that in the night sky, in the evening sky, sometimes you will be able to spot the Mars also. You would be able to spot Jupiter also. That also shines. So it is not a star. But why does it shine? Does it produce enough heat on its own? No, it's simply the reflection of solar rays. Okay, right? Now, the longer questions. Why the shape of Earth is only circular, not in other shapes? What is the shape that you would want the Earth to have? Tell me. I will ensure that that shape is present. But yesterday also I had given you the example, anything which rotates continuously. For example, the dough that you take in order to prepare chapatis, etc. Now you rotate that dough, you make it into a sphere. So that dough is of a random shape. How do you make it into a sphere? By continuous rotation. Any molten material, when it continues to rotate, it will take that circular shape. There is no rocket science behind it. Okay. Lakshmi, I told you that yes, we see a flat surface. At the end of a star, life black hole forms and it has high intensity of gravity and a point singularity. And the Big Bang Theory singularity is, that is a different singularity there. No, it is a different singularity. So when we talk about, is it possible in singularity of black hole, singularity and a blast? No. That black hole is different. So when we talk about the singularity which was present earlier, it was a highly condensed material consisting, which had very high temperature and very high pressure that exploded. Okay, right? On the Dow, there is force of hand. On the dough, there is a force of hand. So if simply by application of force of hand, if you could convert it into a sphere, try it today. Take a piece of dough, apply as much pressure as you can. Will it get converted into a sphere? No, you will have to put that rotational motion. So imagine a liquid which is in outer space is continuously rotating. Can it gain a shape of a cube or a cuboid? No, it will always gain the shape of a sphere. Right? You gave the example of coconut, how it is related to the earth. So in the case of a coconut, the outer shell of it is hard. Okay, it is hard. That relates to the crust. Then the inner portion, the whitish flesh of coconut, that is also solid, but it can be compressed. It can change its shape. The flesh of coconut, if you press the flesh of coconut, it can be pressed. Same is the case with mantle, very dense, but if you, it can be compressed, it can be deformed. And then the inner portion of coconut consists of liquid core. Okay, again, please clear my doubt. Okay, what is your doubt? But heat is decreased as surrounding is colder. Then how earth core is not cooled? Because as the cooling was happening from the outside, the outer portion solidified. So there was not much of a medium from which heat could escape. How do things cool down? When we say a thing has cooled down, how does it cool down? You take out the heat energy, only then it cools down. But that heat energy got trapped, right? And then things started solidifying. That heat energy further got concentrated. So that is where the heat energy, time and time again, it gets lost. That heat energy, every time that a volcanic eruption happens, some amount of that heat energy is released. Every time when the land surface moves, it is because of that heat energy. So slowly and steadily, the earth is losing that heat energy. It is predicted that in the next 3 to 4 billion years, the inner portion would have cooled down quite significantly. Is that understood? Right? If it is just a matter of collision of planetesimal objects, then how does Earth started to rotate? Again, I would repeat, if you have an object like this, which undergoes a collision, it would have some rotation. Again, another collision, it would have some other rotation, and it would continue to move in that way. So it is by that multiple collisions and inertia that the actual movement, that the rotation happens. End of the star is the black hole. Okay, Prabjot, how is it that magnetic forces act as an indirect source? Because when you think about it, why does the planet Earth extend or subtend a magnetic force? That in itself gives you an idea about what that material would be present in the interior. After all, it is the source of information for the interior. How do we know that iron and nickel is present in the interior? How do we know that someone is not lying to us in the interior? Rather than iron and nickel, you have nothing. You simply have gold there and nobody wants you to know. You do know that because of the magnetic field which is subtended. So magnetic field of the planet Earth helps you understand what is present in the region of the core. Okay. Asteroid don't have gravity. Who told you? Naina, why only collision took place? Why not fragmentation? Collision will lead to fragmentation also. But if you have two objects, let's suppose, who are moving against each other, that collision will lead to fragmentation. That happened in the case of Theia. But when you have an object moving like this, another object comes with a larger object, comes with a force and basically subsumes that. There will be heat produced, but it will not get fragmented. Right? That is a portion of momentum, conservation of momentum, and the impact of it. That is the portion of physics I don't want to get into. Will on rotation of Earth, does Earth will rotate outside of its orbit? No. Is there a chance that Earth will stop rotating? No. Why not? It rains in the sun. What is required for rain? Water. Water is required for rainfall. In sun, what is it that you have? What do you think the sun is made up of? Girish, what do you think the sun is made up of? What gases? Hydrogen? Hydrogen combines to form helium. Can hydrogen form rain? No, you need water vapor. So that is why we call Earth is tilted, as we know a circular material has no tilt or no cone. Because when we talk about the planet Earth which rotates, it is rotating like this. We know that. That is why we say it is tilted. Few of the planets, they basically rotate like this. Or a few of the planets even rotate like this. That is how we know that this must be the axis, this must be the axis. That is how we know it. That it is tilted. Okay? Can we move ahead? During the Big Bang, from where did that singular particle? So, Big Bang theory assumes that there was that singular particle. It does not talk about the origin of the singular particle. That is where the oscillating theory of the origin of universe comes into existence. And I would tell you that, but not at the risk of confusing you guys out of your comfort zone. Basically, the oscillating theory, which is supported by the many of the physicists, is the fact that every few years, in the terms of every few multiple billions of years, the universe basically ends up, due to that Big Bang, it expands, it will move away, keep on moving away. Eventually, it will lose the energy. That is when the things, because they have lost their energy, they will be pulled by the gravitation of each other. They would start coming together. That is where they will again form that singularity. Again, there will be explosion. Again, it will lead to formation of the entire new universe. Again, everything will be condensed into the smaller part. If the moon was not formed, what is the effect of gravity in Earth? It would have been more powerful. Okay. Is that taken care of? Any of you who have that urgent doubt without which life becomes difficult? Any of us having that urgent kind of a doubt? How the cooling happens after volcanic eruption? It gets into the contact with the colder atmosphere. The outer surface, even now, when the volcanic eruption happens, the molten materials, do they remain molten all the time? They cool down. Why? Because in the interior there is heat, on the outside it is colder. So 800 degrees Celsius, 1000 degrees Celsius materials, when they come out, they get in contact with the 40 degrees Celsius air. It will cool down, it will solidify. Who first propounded the theory of Big Bang theory? Lemaitre and Gamow. Is optional geography similar with prelim syllabus? The syllabus is going to consist of these portions, but then optional, you have to study things in much greater detail. Where can I find geography current affairs? I'm not finding it in Hindu. If they're in what section? It will come. So, for example, a cyclone has occurred. That is a part of the current affairs of geography. That why a cyclone happens, if an earthquake happens, why it happens, if a landslide happens, where it happens. All those portions are the portions of current affairs. Okay. Are we comfortable now? Can we take a breather now? Okay. No, we can't. Since there was vacuum in the earlier time, how did crust cool down? As the number of collisions happened, as the number of collisions reduced, you had lesser number of collisions. So there was nothing which could produce heat anymore. So that is why the surface would lose heat to the outside space, outer space. And that is when the surface started cooling down. Okay. Why the stars are always hot as outer space is around minus 200? Because the stars, they continue to produce heat due to the process of nuclear fusion. Sun is a star. Sun continues to produce heat because of consumption of hydrogen into helium, and then hydrogen gets converted into helium. So that process continues to happen. It continues to produce heat. Okay. Seismic waves are the waves generated during an earthquake. Okay. Now we come to, any of the remaining questions that you have, take a glass of water, sip it in. After some time, even that will be cleared off. Now we talk about the aspect of the interior of the Earth, or the structure of planet Earth. So when we talk about the structure of planet Earth, it is largely divided into three major layers. The thinnest layer, the thinnest and the lightest layer. Listen to this very carefully now, and let's put a hold to those questions now. 25 minutes I have addressed the questions. Let's put a hold to those questions. So the earth basically is divided into various different layers. The thinnest outermost layer, which is also the lightest layer, the layer that we live in, that is actually the lightest layer of the planet Earth. That is what is known as crust. Crust is brittle. Brittle means it breaks easily. It does not get stretched enough. If it experiences some amount of forces, it can break easily. So crust, because it is the coldest portion, it breaks easily. I hope we are aware that when materials, they get very cold, they break easily, right? Otherwise, you can stretch them, etc. For example, rubber. Take the case of rubber. Under its natural condition, if you stretch it, it can get stretched. But a frozen condition of rubber, it will break easily. That is the condition of crust. It is not frozen, but it is the coldest portion. It is the thinnest layer. So that is why it breaks very easily. It is brittle. That is why volcanic eruptions do happen. That is why when the internal forces, they try to exert forces in different parts of the planet, their surface simply gives way, it breaks, leads to earthquakes, etc. Then you have the portion in the interior of the crust, which is the bulkiest portion. That is what is known as the mantle. It is solid. Mantle is solid and it is very, very thick, but it is heated solid, so it can be deformed, stretched, etc. Its temperature is higher as compared to the region of the crust. Then comes the innermost portion, which is the core. So here you will find the outer core is in a molten state. Core has got two parts. Outer core is in a molten state. So here we find a trend that as you start going into the depth of the planet Earth, the temperature tends to increase. That is what is referred to as geothermal gradient. So as you move into the interior, the temperature increases. That is geothermal gradient. Temperature increases with depth. Okay. Now, so by the time that you reach the region of the outer core, the temperature is quite high. That is why the materials exist in a molten state. But inside that region of molten outer core, you have a very hot solid. That is the inner core. Inner core, as you can see here, is in a solid state. This portion is in a solid state. Why is that? Despite the higher temperature, inner core is in a solid state. Now, before all of you frame the same question, listen to this carefully. You will be able to understand this. So the inner core is in a solid state, but the outer core is in a molten state. Both of them experience very high amount of temperature. Yes, majority of you are correct here. The reason behind this is simple. That is pressure. For example, if you consider a solid object, okay, now if you heat it up, it will get converted into liquid. So it will get converted into, so in the case of solid, the molecules, they are attached to each other, closely bound to each other, isn't it? But if the solid gets converted or were to be converted into a liquid state, the molecules basically, they move away from each other. So we can say that liquid is basically an expanded form of solid. In order for a solid to get converted into a liquid state, it needs to stretch, it needs to expand, it needs to increase in volume, isn't it? But what if this solid has got enough pressure applied from all the sides that it has got no space to expand, no space to increase its volume, let's suppose. In that case, what will happen? If it has got no space to expand, regardless of how much you increase the temperature, what will be the case? It will continue to heat up, but it has got no space to expand. And expansion is needed. That is when the molecules, they will be able to stretch away from each other. So that is where it will continue to remain in solid. So in the region of inner core, the pressure from the surrounding areas is so high that it has got no place to expand. That is why it continues to stay in the solid state. Now, again, a follow-up question will be, but what about the outer core? Outer core is also present in the same area. Why that differential treatment? Why outer core is in liquid? Because even outer core has got a thickness of more than thousands of kilometers. So when we talk about the extent of the outer core has got a, it starts above the region of outer core, you have the surface of 3000 kilometers. But again, after that, you have substantial distance. So outer core has still got some area to expand. But by the time that you reach the innermost, you don't have any space to expand. Okay, that is why. Then another question which generally is followed here. But you have said outer core is liquid. Can't the liquid make some space for the poor inner core? In that liquid, can't they readjust ever so slightly so that the inner core can expand and convert into liquid? No, because the liquid of the outer core is also significantly dense. That is why it does not provide any space for the inner core to expand. So inner core is in a solid state because of very high amount of pressure exerted from all sides, and hence no space for expansion. Okay, so that is why the inner core continues to remain in the solid state. Crust is a thinnermost, mantle is quite thick, and then comes the region of the core. So that is the structure of the interior. So this is the structure of the interior when analyzed. Here, if you will observe, the radius is close to around 6,370 kilometers. Now, again, let me specify, crust and mantle is in a solid state. Crust and mantle is in a solid state. Outer core is in a molten state. Inner core is again in a solid state. Okay. Now, when we talk about the region of the crust has got a thickness of 20 to 50 kilometers. In certain areas such as the Himalayas, the crust has thickened even to the extent of around 70 kilometers, but that's it. Underneath the oceans, the crust is around 20 kilometers deep, and then begins the portion of mantle. Okay, so crust is around 20 to 30 kilometers, sometimes even around 40, 50 kilometers. That is your solid crust. Then begins the solid portion of mantle. Okay, immediately below the crust begins the solid portion of mantle. However, in the region of mantle, you have at a depth of close to around 160 to 200, sometimes even 400 kilometers depth, you have a layer where the materials, they do exist in a semi-molten, semi-solid state. Above it, in the portion of mantle, you have the solid mantle. Below it, again, the mantle is solid. It is just in this layer that you consider the portion is having semi-solid, semi-molten materials. I will come to why that is the case. But you can say that above it, you have the portion of solid upper mantle, above it, the solid crust. This portion of the weaker semi-molten semi-solid is also considered to be a part of upper mantle itself, because mantle, which starts extending right from a depth of 50 kilometers, extends all the way to around 3000 kilometers in depth. That is the entire extent of the mantle. So even this particular layer, which has got the semi-molten semi-solid substances, that is known as asthenosphere. So even that asthenosphere is considered to be a part of upper mantle itself. Okay, but if you go into the specific, above asthenosphere also you have the portion of solid mantle. So this is the portion which is known as asthenosphere. It is derived from the term asthenos, which basically means weak. Asthenosphere. Here you have the solid crust plus solid upper mantle, both of them together, that is what composes lithosphere. So when we talk about lithosphere, lithosphere basically consists of the portion of the solid crust along with the solid upper mantle that is included in the portion of lithosphere. Underneath that lithosphere, you have a weaker region where you have semi-molten, semi-solid materials, that is the asthenosphere. Now, when I say semi-solid and semi-molten, I'm not saying molten, neither am I saying solid. So, what is that conundrum? So, it is not completely solid, not completely liquid. For example, if you take the case of molten glass, it does not flow like a liquid, does it? Molten plastic, it can get stretched, it can be in a molten state, but it does not move like a liquid. Neither can you classify it as a complete solid, can you? So that is the condition of asthenosphere. Asthenosphere is in a semi-solid, semi-molten state. Now, why is that the case? That is because at these depths, you find the sudden dominance of certain radioactive elements. Radioactive materials such as uranium and potassium, they are dominant at these depths. Okay. And owing to the geothermal gradient, that basically means that as you start going into the depth, the temperature is increasing. At these depths, the temperature is also high. The pressure exerted from above is also high. So that is where these radioactive elements, they undergo a thermonuclear reaction. And as a consequence of that thermonuclear reaction, they produce so much heat that all the materials around it, they are partially converted into semi-molten, semi-solid state. Okay, so here at this depth, so don't think about it that so that means all the uranium is found there, and we have been searching for uranium in Australia, Kazakhstan, Canada, etc. But you are saying uranium is present in asthenosphere. No, the surface uranium that we talk about, the mineral extraction that we talk about, that is different. This is at a depth of more than around 160 to 200 kilometers, so significant amount of depth. Okay, so at this depth, you have the dominance of radioactive elements like uranium and potassium. Now, it is not plutonium, it is potassium, the isotopes of potassium. Under high heat and pressure, they undergo radioactive or thermonuclear reaction, produces high amount of heat, very high amount of heat, and due to that heat, materials around it, materials partially melt under very high heat. That is why at that region of asthenosphere, you have the semi-solid, semi-molten state. So asthenosphere is also considered to be a part of the upper mantle. But lithosphere, when we say lithosphere, lithosphere consists of the solid portion. Why both of them are upper mantle? Because a mantle whose thickness can stretch for 3000 kilometers or so, there 200 kilometers or 150 kilometers, they don't make that much of a difference. So above it also mantle is solid, below it also mantle is solid, below it also it is solid, right? So it is only in that layer of asthenosphere where you will find the material to be in a semi-molten, semi-solid state. It is in fact this asthenosphere which is the supplier of all the molten materials that erupt on the surface in the form of volcanic eruptions. All of them, they come from the region of asthenosphere itself. Okay, Now let us take a look at the written portion of it. So crust is the outermost solid part of the earth. It is brittle in nature, means breaks easily because it is very cold. As compared to the inner portion, it is the coldest portion. Now here, the crust is made up of various different types of materials. Okay. Now, and its thickness also varies. For example, in the continental areas, its thickness, basically mean average thickness is around 30 kilometers from the surface. In the region of oceans, its mean thickness is around 5 to 20 kilometers, that's it. Right? So underneath the oceans, the crust is what is known as the oceanic crust. Oceanic crust is thin. Continental crust is thick. But they are made up of different materials. That is why they have different densities and different weight. Continental crust, regardless of its thickness, is always going to be lighter, very light. Oceanic crust is always going to be very heavy. Continental crust is dominated. When we say continental crust, it is dominated by materials such as granitic rocks. It is dominated by granitic rocks. So elements such as silica and aluminium. Silica and aluminium dominate that. And when we talk about oceanic crust, it is said to be dominated by the basaltic rocks, which have iron content, magnesium, etc. High density. I hope we are aware about the term density. We have come across the term density earlier in our lives. Okay, we are not aware about density. Density is basically how closely the molecules are. What is the closeness of the molecules? So density is mass per unit volume. So in the same volume, what is the weight? Right? Take, for example, thermocol and take the case of iron. Thermocol, you can have a large volume. It will be still very light. Iron, even if it is of a smaller volume, it will still be heavier. Right? For example, if you talk about iron sheets are and steel columns, they are very thin. Near it, take a very thick thermocol piece. Volume of thermocol will always be high. But which will be heavier? Iron or thermocol? Always iron. Always iron will be heavier. So why? Because in thermocol, materials are not closely packed. Iron materials are very closely packed. Right? So basaltic rocks, they are made up of silica, magnesium, iron in dominant. Density means dravyaman, ghanatva. Yes. So all those of you who can basically take that into consideration, that is also the meaning of density. Ghanatva is something that I was aware of. Dravyaman is a new translation that I came across. Thank you for that. So basically, basaltic rock is dominated by silica and magnesium. Hence, it is more dense. Density is higher. Always, oceanic crust is going to be heavier as compared to continental crust. Always. Regardless of the thickness. Oceanic crust is heavier as compared to continental crust. Okay? Always, oceanic crust is going to be much heavier as compared to the continental crust. So the continental crust is thicker in areas of major mountain systems, in the regions such as Himalayas, where there is a crustal compression which happens. The crust can be as thick as around 70 kilometers. Right. So the continental crust, composed chiefly of granite, has a density of around 2.7 gram per centimeter cube, And the type of rocks found in oceanic crust is basalt, where the mean density is around 3 gram per centimeter cube. So that is why basically you will find that significant amount of weight is associated with oceanic crust. This is going to be always going to be heavier. Then after the region of the crust, which is the thinnermost portion, that is where you come across the region of mantle. Mantle is very thick and it is also dense. Density, by the time that you reach the lower regions of mantle, the density is very high. So average mean density in the portion of mantle is close to around 3.4 gram per centimeter cube. Mantle starts in extension or starts in existence right underneath the portion of the crust, and it can extend up to a depth of around 2990 kilometers or up till around 3000 kilometers. You will find the depth of the mantle. So that is significantly thick. Now, it represents around 68% of the Earth's mass is represented by the region of mantle itself. That is how voluminous it is. Okay. However, in the portion of the mantle, in the upper portion of the mantle, you have the asthenosphere. Now, asthenosphere is derived from the term astheno, which means weak. It is considered to be extending up to a depth of 400 kilometers from the surface, and it is the main source of magma, the molten material, which finds its way to the surface during major volcanic eruptions. Then we come to the region of the core. Now, core is the innermost layer of the planet Earth. It is dominated by iron and nickel. The temperature is so very high that the outer core is in a molten state, but the pressure is so very high that the inner core, despite the high temperature, continues to remain in a solid state. So when we talk about the region of the core, because of the dominance of iron and nickel, that is why it is also what is known as the Nephi layer. Okay, Ni stands for nickel, Fe stands for iron. So the core mantle boundary is positioned at a depth of around 2900 kilometers. The core makes up around 31% of Earth. Inner core is in a solid state, whereas the outer core is in a liquid state. Okay, it is made out of heavier materials. Now, if I talk about the basic question, while writing the notes, is it important to draw the diagram in the notebook? It depends on you. If you can retain that diagram, you can basically reproduce it in the examination, fair enough. So basically, I want you to apply logic here. When we talk about a region in the crust itself, let's zoom in the crust. Now, if I ask you the pressure exerted by the rocks here, let's name it as A, and the pressure which is experienced by the rocks here at B, where do you think the pressure will be higher, A or B? How in A the pressure will be higher? What is the logic that you have provided for A, the pressure being higher? Or is it simply because that he was saying A or B, I had 50-50% option, so I chose A? So kindly could you elaborate, few of you? Why do you think that pressure will be higher at A? No, now converting your answer to B doesn't work. If you have written A, okay, atmosphere. Okay. Okay. Basically, the pressure will be high at B because here you have only few, maybe 1 kilometer of rock above it. So that is going to extend the pressure. Here you will have many kilometers of rocks above it. That is going to extend the pressure. So as you go into the depth, the pressure increases, the temperature increases. Due to the increase in pressure, due to the increase in temperature with depth, eventually you will find that the molecules, their pattern changes. The type of materials, they start to change. You have different arrangement of particles, different chemical properties exhibited and indicated by the particles. So as you start moving into the depth, in the crust, in the portion of the mantle, you will find that the nature of materials, the nature of the rocks, all of them, they undergo a kind of a change. So there is that zone of transition from where different kinds of materials will start dominating. And that zone of transition, that is what we refer to as discontinuities. So, for example, from the region of the crust to the region of the mantle, as you go from crust to mantle, the nature of materials, the nature of rocks, they will change. As you move from mantle to the region of the core, the nature of materials, the state of materials, everything will change. So that transition is known as discontinuities. So basically, planet Earth has got various different discontinuities in the interior. Now, this is going to be relevant. The name and where it is present that match the following kind of question can be asked in from this particular portion, particularly in your prelims examination. So here, when we talk about the region of the crust, you have a discontinuity which distinguishes the outer crust from the upper crust from the region of lower crust. And that is what is referred to as the Conrad discontinuity, which basically differentiates the nature of the rocks that you find closer to the surface. But as you go to the depth of the crust, the material arrangement, etc., changes. Then, between the crust and the mantle, that boundary between the crust and the mantle, there also you will have the different types of materials which are present. That is what is known as Mohorovičić discontinuity, okay, or what is simply referred to as the Moho discontinuity. In geological terms, it is sometimes simply referred to as the Moho. For example, when an earthquake occurs, you will hear in the, or if you read the detailed analysis of it, if ever, you'll find it mentioned there that the origin of the earthquake was 12 kilometers from Moho, was 15 kilometers below Moho, was closer to Moho. So Moho basically stands for Mohorovičić discontinuity, and that is the discontinuity which differentiates the region of the crust from the region of the mantle. So Mohorovičić discontinuity differentiates between the upper or between the region of the mantle and the region of the crust. Then in the mantle also, you have the upper mantle and the lower mantle. They are also separated by a discontinuity. And that is what is Repetti discontinuity. All of them are named after the individuals who basically found that. Then after that, the outer core is molten. The portion of the lower mantle is solid. So there also you will have a discontinuity. And that is your Gutenberg discontinuity. Then the outer core is liquid, inner core is solid. So there will be a demarcating layer or that zone of transition between the liquid outer core and the solid inner core. That is what is known as Lehmann discontinuity. So these are the various different discontinuities which basically demarcate the different types of materials or the variation of materials as you move from the surface to the depth. Okay, these are the various discontinuities. So discontinuities simply tell us that, for example, the surface of the crust, different types of rocks. If you go to the depth of 50 kilometers, you will have different types of rocks. You will have different pressure exerted, so the molecular arrangement will be different. The pattern will be different. The chemical properties will be different. So there will be that zone of transition which will be created in between. That is the discontinuity. So discontinuities, they get created due to overlying pressure, temperature, nature of materials. For example, mantle and core. Mantle is solid, core is liquid. So there will be a region where above it you will have solid particles, beneath it you will have molten portions. So that is the case of discontinuity again. So this is the portion or the reality of the discontinuity. For your prelims, you can have the match the following. That Conrad, which it is between upper and the lower crust, Moho between the crust and the mantle. This kind of a match the following question can easily be asked in the prelims. For your general studies, it will be sufficient if you are aware about what is Moho between the crust and the mantle and what is Gutenberg, right, between the solid mantle and the molten core. So these discontinuities, you take care of it, your portion of GS prelims is taken care of in this area. Now after this, we come to the minerals. Basically the minerals which are present in the interior of the earth. Here also questions have been asked previously about which minerals are dominant in the interior of the planet. So when we consider earth as a whole, inclusive of the surface, the interior, everything, iron is the most dominant element, followed by oxygen, followed by silicon, magnesium, and so on. Now here oxygen. How is it that oxygen is present in the interior? What do you think? How is it that oxygen is present in the interior here? Are we able to think about it? Yes. Amritansh, good. Godavari, good. This oxygen, when we talk about, it is present in the form, Debanjan, very good. Anant Krishnan, good. This oxygen is present in the form of oxides, the solid form, right? You will find iron oxide, silicon oxide, etc. So that is where this oxygen is present in the oxide form, okay, present in the form of oxides, solid form, in the form of oxides. Example, silica, ferrous oxide, alumina, etc. If you consider only the Earth's crust, there oxygen is the most dominant, followed by silicon, aluminium, and iron. For your examination, this is the portion relevant for your prelims. For your examination, only the top 4 need to be studied. Only the top 4 need to be covered for your examination here. Now, this oxygen also is in the form of oxides. It is not the gaseous oxygen that we are talking about. We are talking about the surface and the interior. So here also we are going to talk about the oxides only. So here also the top 4, that is something that you should ideally keep in mind. Okay. Now, then we come to the portion of rocks. So when we talk about rocks here, but before that, let us talk about something different. Let us talk about geomagnetism. That is magnetic field. Extended by Earth. Now, when we talk about planet Earth, we know about the structure now. I hope we know about the structure now. Now, when we have seen the structure, we have also seen that in the region of the core, you basically have the molten outer core, and then you have the case of solid inner core. Molten outer core, solid inner core. Okay, before that, I don't know how many of you are from science background. I am assuming that none of us are from science background. So in that case, I hope we are aware of a phenomena that if you have a kind of an electricity which passes through that circular spiral, let's suppose you have a circular wiring like this. Are we aware about electromagnetism? Have we heard about the term electromagnetism? Right? Where magnetic field is subtended with the help of electricity? Yes? Now, yes, this is a solenoid, but again, so as the electric current passes through here, this basically subtends a magnetic field like this. Okay, so passage of electric current in a spiral extends electric or a magnetic field. Were we aware about this? No? You would have heard about the maglev trains in China, right? Where are you going into Faraday's law, etc.? That is like too much into science. I am going to bring it down. Ashish, I hope you are aware about it, that many of the candidates are not from science background. So if I use Faraday coil, etc., that will create a panic which will be unparalleled. So you would have heard about the maglev trains in China. Maglev trains basically is, I hope you are aware that in China you have the train system which can move at a speed of around even 500 km per hour, 600 km per hour, and that works on the property of magnetic field, where the train simply doesn't move on rails, it floats on the railway track. It kind of floats because of the magnetic field. It does not touch the rail. It simply tends to float on one on the other. And that is why it is able to gain a speed of around 550, 600 kilometers per hour. Right? That works on this principle of electromagnetism is with the help of electric current, you are able to produce a magnetic field associated. Even if we don't know it, are we able to digest this reality of life? I understand that yesterday many of us were unable to digest that reality, that how come poles are in darkness. Nobody told me till now. So are we able to digest this reality? Fair enough? Okay. Now, if that is the case, so here, now let us talk about the Earth. Earth is consistently rotating on its axis from west to east. In a direction west to east, Earth is consistently rotating on its axis. So as the planet is consistently rotating on its axis, you have the molten outer core, which is in liquid state. Means very high temperature, right? Molten state, very high temperature. So that means that molten outer core, liquid, is also moving in a kind of a circular motion. Because of that very high temperature, that particles of iron, nickel, etc., they have electrons which escape the molecule, or the electrons which escape the atom. So you have presence of movement of electrons and ions. Charged particles, they start moving in the region of charged particles. Basically mean, if let's suppose in an atom an electron escapes, it is a charged particle, right? So as at that very high temperature, molten iron and nickel, they continue to rotate in a circular motion. You will have the electrons which also start moving. So the charged particles, they continue to rotate in a kind of a circular motion. And when they rotate in a circular motion, it will be like passage of electricity like this, because electrical current is also about the movement of electrons. So that is when it will be like the movement of the charged particles all around it. And that will subtend a magnetic field. That will basically subtend a kind of a magnetic field. So this magnetic field which is basically subtended, that is what is referred to as geomagnetism. So that geomagnetism is extended because the planet does rotate and because the outer core does rotate. So the outer core rotates in circular motion due to high temperature, charged particles of iron and nickel move in circular motion. It extends a magnetic field. That is geomagnetism. That is what we refer to as geomagnetism. Okay, so that is the case of geomagnetism, because as the outer core also rotates, planet rotates, outer core is in a liquid state, so the outer core will also rotate. Outer core consists of what? Iron and nickel. So at high temperature, it can happen that one electron of an atom will escape. So as it rotates the outer core, we can also think about it that the electrons or charged particles are rotating in a circular motion. Whenever they are rotating in a circular motion, they will be subtending a magnetic field. That is geomagnetism. Now for your general studies, even if you know that Earth subtends a geomagnetism, more than sufficient. Nobody is going to ask you the detail about it. Okay, even if you know that planet Earth, because of the movement of the rotation of the outer core, it produces a magnetic field, more than sufficient. Now Here, when we talk about, for example, if you talk about the compass, right? The compass readings that you get, compass always points to the north. Now, that compass, why does it point to the north? It is based on the magnetic field of the planet Earth, right? Now, here, if I elevate this level of concept, I hope you are okay with this particular level of concept. No, this is different from the force of gravitation. Force of gravitation is the force of attraction. Magnetism is different. Iron magnets, they, you would have seen fridge magnet, basically, if you see it, that is magnetism. If that magnetism is induced because of movement of charge, that is electromagnetism. Okay, now here, when we talk about the region of outer core, it consists of iron nickel in a molten state, but will that be in the same molten state like you think of water, or do you think it will be slightly viscous like honey, for example? Just as a point of reference, I'm giving you. Don't quote me that outer core is consisting of honey because it was told in the class. No. I'm just telling you about it. That iron and nickel in a molten state, will that be in a state of fluidity like water, or will that be viscous like honey? Slightly viscous, isn't it? It will slightly be viscous. So it doesn't flow very easily. So it can happen that outer core sometimes will have a chunk of iron and nickel, let's suppose developing somewhere, a large bulk of it developing somewhere, concentrating somewhere. That is where the rotation is happening. Let's suppose from here that chunk has traveled all the way till here. Now that will impact the magnetic field. That will mean that the magnetic field now starts extending from here. So that is why, because the outer core, excuse me, because the region of the outer core consists of these materials, and these materials, they can simply end up moving from one region to another in bulk, in large quantums. That can have a potential to impact the magnetic field. And that is why the magnetic poles of the earth, they are prone to shift. Magnetic poles of earth, they are not fixed in the same place. They are prone to shift. You might have sometimes the magnetic pole coming here, sometimes the magnetic pole coming here. In 2020, for example, the magnetic north pole of planet Earth, that shifted from the region underneath the area of Siberia to the region underneath Alaska. Because in the region of the core, you had that massive shift from the region of the bulk of iron and nickel moved from one area to another. Now, the magnetic poles of planet Earth, poles of Earth are prone to shift from one region to another, and can also revert in polarity. That is the concept of geomagnetism. So, if I ask you a question, ever since the formation of planet Earth, the magnetic field of planet Earth, or the magnetic poles of planet Earth, have changed multiple times. True or false? What do you think? True? Very good. This was the question which was asked again in 2018 prelims. So, if you can think about it, you can get those questions correct as well. So, that is the concept of geomagnetism. Okay? Now, this geomagnetism basically has got its influence in the form of the northern and the southern lights. So, when we talk about magnetism, so we do know that planet Earth subtends a magnetic field. Now, the properties of the sun, which you study in the portion of science and tech, sun time and time again discharges heavy amount of charged particles into the solar system in the form of solar winds and solar flares. The sun ends up discharging very large amount of charged particles. Okay, in the form of solar winds. Now these travel. These charged particles, they are emanated in the form of solar flares and solar winds, which end up moving at a speed of thousands of kilometers per hour. And they end up reaching the region close to the planet Earth. But as they approach the planet Earth, these charged particles, they are influenced by these magnetic field lines. And that is when they will always go to the area where the magnetic field lines have the greatest density. And which is the area where the magnetic field lines have the greatest density? Around these regions, higher latitudes. This is where magnetic field lines will have the highest density. So that is when these charged particles, they end up traveling like this. They go for an angular shift. In fact, the Aditya L1 mission which we have sent, one of the prime purposes of that Aditya L1 mission is to study that angular shift, is to basically work upon and understand how that angular shift happens. So basically, that is how that shift does take place. Now here, you will find that as they reach these region closer to the poles or the higher latitudes, these charged particles, they interact with oxygen molecules, nitrogen molecules which are present in the upper atmosphere. And that interaction with oxygen and nitrogen, that produces very unique and picturesque hues of light. That is what we refer to as auroras. In the region of the northern hemisphere, closer to the poles, that is in the region of Norway, Sweden, Finland, Greenland, northern Canada, Siberia, and also the region of the Arctic. That is what is referred to as northern lights. Every year, thousands of tourists, they do visit these areas to witness the northern lights. So auroras, you have northern lights, or what is also known as aurora borealis. And in the southern hemisphere, they are known as southern lights. People do visit New Zealand and Australia every year to witness these southern lights, where the sky basically is painted green, blue, and various different hues of color. It is like a river of light which flows into the night sky. So this is also what is known as aurora australis. So that is basically the magnetic field which does impact the charged particles emanated from the sun, and that is why these areas, they experience this. Okay, so that is the situation or the condition why we experience northern and the southern lights. This is where we'll limit the discussion here for today. I want you to digest this, revise this. Tomorrow we will continue from the portion of the area of rocks. Auroras basically are produced when the charged particles of the sun, they get emanated from the sun on a very regular basis. And whenever they get emanated from the sun, that is when they will come towards all the planets. And when they approach the region of the earth, they will basically aided and impacted by the magnetic field. They basically get directed towards the region where the magnetic field lines are of greatest density. And that is when they will come to the polar areas. Okay, so that is the case of why when they interact with the oxygen and nitrogen molecules at our upper atmosphere, they end up emanating light. Okay, Shiva, find it on YouTube. You will find the IDL, search it on Byju's exam prep, you will find that. So this is where we'll restrict the discussion here today. You have the webinar sessions also. And Seema, if the outer core has iron in the whole section, then why magnetic pole shift? Because in certain areas you have a greater density, in certain areas you have less density. So as that greater density region shifts, the magnetic pole also shifts. In lithosphere, which is the outermost crust or uppermost mantle, the crust plus the uppermost solid portion of mantle taken together, Sushmit, that is lithosphere. Why can't rotation of solid mantle and inner core? Because you need the movement of the charged particles in a circular manner to extend that magnetic field. Okay, Then why magnetic field felt in pole only, not all over the Earth's surface? Because it rotates in this manner. So as it rotates in this manner, the magnetic field will be perpendicular to it. Yes, Rumaiza, I answered your question earlier also, that while writing the notes, is it important to draw the diagram? Whatever is required for you to recollect the diagram, that is sufficient. Groundwater is present in the upper portion of the crust itself. So that is where we restrict the session here. We meet again tomorrow. Take care of yourself. Goodbye. Attend the webinar sessions and we will continue tomorrow. Thank you. Goodbye. Have a good night.